Okay, so what you're going to do today in KVA is, if you do not have a TI Nspire, we're going to get your equations for the line using Google Sheets. So I'm going to come up here. I'm going to be logged into my school Google account. I'm going to go to Google Sheets, okay, and I'm going to pull up a spreadsheet. Now I've already got it set up and ready to go. Let me move this over just a bit here. And so you can go ahead and pull up your empty sheet. And I'm going to title this Rate Graphing. Oops. Oh gosh. Rate Laws. Now this is problem number 1 of the handout of the Google Sheet, right? So I've got time T, and this is my time data. This is from problem number 1. On the 3rd page under conclusion questions of your handout. Your concentrations are here. This is the decomposition of N2O5, and here are my concentrations. Now what I want to do is to graphically determine the order of my reactions. Remember we talked about yesterday. We're going to do 3 graphs. We're going to graph T versus concentration, T versus log of concentration, and T versus reciprocal of concentration. I'm going to call that R, and see which one is linear. So here's my data. So what I'm going to do now is I'm going to go ahead and fill in the rest of the data. So let's call this log of concentration of C. And then this is going to be, I'm going to call this one the reciprocal of C. Okay, so you can pause this video whenever you need to and go ahead and fill in your Google Sheet, but I'm going to go ahead and go on. So once I've got these columns, what I'm going to do is I'm going to let Google Sheets calculate all my natural logs. So remember, we're going to tell Google Sheets to make an equation by typing equals. I'm going to say take the log, there it is right there, there's my parenthesis, of this cell, close parentheses, enter. Once I do that, I can take this, drag it, and it does it for all the cells. Then I want 1 over the concentration. So again, I'm going to tell it equals 1 divided by this cell. Enter. Then I can go through here and make it do that for all of them. All right, so what I want to do now is I want to do some graphs of this data. So the first graph I'm going to make is T on the x-axis and C on the y-axis. So I'm going to highlight those columns, go to Insert, Chart, and there it is. Now I'm going to make this a little bit smaller. Now you can already tell from this graph that this is a curve. We're just going to do this by inspection, right? We're going to do this by inspection, and that's a curve. That's not exactly what I wanted. So let's go up here and do a different graph. This time, I'm going to graph T versus Ln of concentration. Now to do this, what I'm going to do is I'm going to highlight, I'm going to hold the key down, the mouse down, and pick up my finger. Then I'm going to hold the control key down while I'm dragging this column. This tells Google this is my X, this is my Y. I do the same thing. I go into Insert Chart. Now for some reason it's choosing a bar graph for me. I don't want that, so I'm going to go over here to Setup, and I'm going to choose Scatter Plot. It also for some reason is not using my columns as labels. So make sure these 2 bottom boxes are checked, and that will give you the graph that you want. So now we're going to look here. And then I'm going to do my last one. My last one is to graph time versus the reciprocal of my concentration. Remember to hold your control key down, go down like this, go to Insert, Chart, and again, this time it did give me the kind of graph I want, and I'm going to put this over here. Now if I were to notice by inspection, I would note that both of these are a curve. So it looks to me like this is a first order reaction. And what I'm going to do to test that out is I'm going to find the equation of the line and the r squared value to make sure that is the case. So I'm going to come up here to Customize and Series. I'm going to move down here to Trend Line. That's going to be, whoops, that's the wrong one. Sorry about that. Let me go here. Sorry, we'll go to this one. I'm going to go to Edit Chart. I'm going to come over here to Customize, Series, go all the way down to Trend Line. There's my trend line. And come over, if you scroll down a little bit more, you go to Label. That will get me my equation and r squared. If you look at my r squared value, that is a 1. Let's go over here to this one. If I look at my r squared value for this one, it's a 0.985, which is good, but not as good as this one. So what this tells me is that this is a first order reaction. And this is my equation. So what I'm going to do is I'm going to write these out. So the first, in the conclusion questions, let's move to, this is my equation. What that means is, I'm going to pull up my hovercam. What that means is, that equation says that y is equal to negative 0.03754 times x plus 0.84632. Now, the numbers may be slightly off because I'm using the calculator to actually get this equation of the line, but that's what this says. The way that Google Sheets works is they're only giving you, this means y is equal to that. There's my x plus b. So that's the equation of my line. So now I know that this is a first order reaction. Okay, so let's go back and answer the questions for the first part. I know that this is a first order. I know that my K is 0.3754 seconds to the minus 1 because it is the slope of the line. My rate law is rate is equal to K times N2O5. Now, let's calculate D. D asked me what is the concentration of N2O5 at 2 minutes? All right, so what I'm going to do is I'm going to use my integrated rate law, and I'm going to solve because this is my first order integrated rate law. This is just like what we did in our warm-up today. I'm going to go ahead and substitute. If this is my y-intercept, this number is here. So I can substitute, right? Because that is my y-intercept, mx plus b. So that's going to be minus 0.84634 is equal to, I know what my k is, a negative 0.0375 times 2 minutes. I go ahead and rearrange everything, and I get 0.84634 minus 7.5 times 10 to the minus 2. That means log of A at time t is equal to 0.771. I'm going to take the inverse log of each of these. That cancels that out. That means that A at time t is equal to E of 0.771, which is 2.16 molar. All right, let's solve problem E. Right? Now E, I'm going to use the same equation, but I'm just going to plug. It says that my concentration at time t is 0.55, and I'm supposed to calculate the t at which this occurs. Well, I know this. Remember, this is my y-intercept. This is my slope. Let's go ahead and plug it all in. So the log of 0.55 is equal to a negative 0.03754 0.8754 times t plus 0.84634. I'm going to go ahead and clean this up a bit. Remember, to find this number, I'm just going to hit the log key and enter in the number. 5978 is equal to a negative 0.03754t plus 0.84634. That means at negative 1.44, I'm just basically going to take this and bring it over, is equal to a negative 0.03754t, and t is equal to 38.5 minutes. Notice how all the negatives cancel. Remember to include your signs, they're really important. So you're going to do this for the remaining problems. They're not all first order, so be aware of that, but you should be able to use Google Sheets to find out what order it is, and then use the equation of the line when you hit trend line and use equation to actually be able to solve these.